Hi, in this video we're going to look at the GCSE Higher and Foundation topic of highest common factors and lowest common multiples, also known as HCF and LCM. As ever, for more information or to ask any questions, you can follow me, Mr_G_Walton, on Twitter, or you can follow the school account at Tupton Maths. Have a look, see what we're going to do in this video then. So the three main objectives we're going to look at are to be able to calculate the highest common factor, also known as HCF, between two or more numbers. We're going to look at calculating the lowest common multiple, or LCM, between two or more numbers, and to be able to do both of these we need to be able to carry out prime factor decomposition, which sounds really complicated and you will have seen it before in class. Your teacher might have called it the cherry tree method, but you'll get to see this as we go through. The key thing is that you know some of your prime numbers, so we need to make sure we're happy and we know what a prime number is. This is a key word. We also must know what the word factor means and multiple. These are the three key words we're going to be using in this video. So if you're not sure of these, make sure you've had a little look. Hopefully it'll become obvious as we go through. Prime numbers have two factors, so two factors only. And again, you might have learnt this in terms of numbers that are only in the one times table and its own times table, or numbers that only two numbers go into. That's another possibility, one and itself. A factor is one of those numbers, something that goes into another number. So for example, if I said factors of 12, you might think, well, two numbers that times together to make 12. 2 is a factor. 6 is a factor. 1 goes into 12. 12 goes into 12 if you like that kind of terminology. 3 and 4. These are all factors. Okay, so factors are going to be smaller or the same size as the number that we started with. Okay, never going to be bigger. Multiples, on the other hand, are bigger. So if we had multiples of 4, we're thinking of numbers in the 4 times table. Okay, so these are all multiples of 4. Multiples sounds a little bit like multiply, so we're getting bigger. That might be an easy way to remember it. Okay, let's keep going then. So in this first example, it just basically says write 350 as the product of its prime factors. And to be honest, I've started here because this is where we're always going to start when we're doing highest common factor and lowest common multiple type problems. So we'll start off and we'll write 350, and we're going to try and think of two numbers that multiply together to make 350. Now you can pick any numbers at all as long as they times together to make 350. I'm going to pick an easy pair of numbers, 35 and 10. 35 times 10 is 350. What I'm doing is I'm looking at both of these numbers and thinking, is this a prime number? Is this a prime number? Now, if you don't know your prime numbers, it's well worth writing down the side of your page, or at least learning what these are. Okay, now I'm going to stop probably here. 2, 3, 5, 7, 11, 13, 17 are all prime numbers, and it goes on and on. There's a very large list of prime numbers. You're not expected to know them all, but you are expected to learn these few here. Okay, so 35 and 10. 35 isn't prime, and nor is 10, and I know that 35 isn't because it has factors, or numbers that times together to make 35, that are not just 35 and 1. 5 goes into 35, and so does 7. Now 5 and 7 are on my list of prime numbers over here. So as soon as I've got a prime number, I'm going to circle it, and I'm going to now stop. I don't need to do anything else with that branch, but I am going to now look at the 10. I haven't yet circled 10, so what numbers times together to make 10, apart from 10 and 1, because that's not going to get us anywhere. It's going to be 2 and 5. 2 and 5, looking down my list, are both prime numbers, so we can circle them, and at that point we can stop. Now, I've used a method but I haven't yet answered the question. So it's not enough just to stop at this point. We must now answer the question. And the question said, write it as the product of its prime factors. Product is another word for multiply. So I can write 350 equals. And I'm just going to put these numbers 2, 5, 5 and 7 in order. So 2 times 5 times 5 times 7. And for most of the work that we're going to do in this video, leaving it in this form is going to be actually really helpful to us. However, those of you that are good at spotting little patterns and little tips and tricks and quicker ways of doing things might also notice that we could write this as 2 times 5 squared, because here, if you notice, we've got 5 times 5, which is the same as 5 squared, and a 7 at the end. So that's probably the neatest way to do it. But like I say, the way that we're going to do our highest common factor and lowest common multiple, we're going to leave it in this form. Okay? Right, let's move on. Let's have a look. Now, here it says find the highest common factor of, and we've got two numbers now. So a highest common factor means the biggest number, or the largest number, highest, that is a common factor. And that means a number that's in both 350 and 105. So a factor of 350 and a factor of 105. Now, you'll remember that only a second ago we've just worked out what the factors of 350 were. The factors of 350 we wrote down to be 2 times 5 times 5 times 7. Okay, we'd already done that little bit of work. Let's do the same with 105. Let's split 105 up into its factors. Now, last time I picked two easy numbers, and we could see that because it ended in a 0 before, that 10 was a factor. This one doesn't, but I do know the rule about something that ends in a 5 has got to have 5 that goes into it. So let's do that. Let's see if we can work out how many. Well, 5 goes into 100. I know that. 5 goes into 120 times. And I've got one extra 5, so it must be 5 and 21. Now again, from my list before, I'm just going to write them at the bottom. 2, 3, 5, 7, 11, 13, 17, and so on. These are my prime numbers. 5 is, so I'm going to circle it and leave it. 21 isn't a prime number. I know that 21's in my 3 times table, so I'll split it out again into 3 and 7. Now, in order to do this, you do have to be quite good at your times tables to spot what numbers are factors, but nevertheless, it's a skill that you should have by now. So we're saying that 105 is 3 times 5 times 7. Now you'll notice that I've written this list directly underneath my first list. And what we're going to do now is we're going to see if we can find anything that's common, anything that's in both of the lists. Now, I can see that I've got a 2 in this list, but there is no 2 in this list. Okay, so I'm not going to have a 2 as part of my highest common factor. I've got a 3 in the bottom list, but I haven't got a 3 up here. So I'm not going to have a 3 as part of my highest common factor. But I have got a 5 in this list and a 5 in this list. Okay, so I'm going to circle them to say that I'm using them. So my highest common factor is going to have a 5 in it. It's also going to have a 7 in it because there's a 7 in both lists. So my highest common factor is 5 times 7. Now, you've got to be really careful when you're doing this not to write both down. If there's a pair of numbers, we're just writing 1 down here. And if there's a pair of numbers here, we're just writing 1. So the highest common factor, the biggest number that goes into both 350 and 105, is 35. Now, the question doesn't ask us to work out the lowest common multiple at this point, but I'm going to show you, because we've done nearly all of the work. To find the lowest common multiple, we're going to take the number we've just found, which was our highest common factor, 35. And we're going to multiply that with all the things I've not yet used from my factors previously, which are 2 and 5 and 3, in any order. Remember that when you're multiplying, you can multiply things in any order. And let's see if we can do this. And again, let's see if we can use a little bit of sense rather than trying to think and worry about what we're doing here. 2 times 5 is 10. So straight away we've got 35 times 10, which is 350. So we've got 350 times 3, because I've not used 3 yet. 300 times 3 is 900. And 3 lots of 50 is 150, so altogether we must have 1050. So I've also worked out what the lowest common multiple is. Now, I know the question didn't ask us to, and under normal circumstances I would always say don't do more than what the question's asking you to do. However, in terms of showing you, I thought it would be a useful point to do it here. Okay, here are 2 questions then. If at this point you feel like you want to have a go, feel free to. You can pause the video and have a go here. Alternatively, if you want to watch, I'll show you how you work out the highest common factor and lowest common multiple for these 2 pairs of numbers. Okay, so first of all, we've got 24, and we're going to have to split that up into its prime factors. So 2 numbers that times together to make 24. I'm going to go for 2 and 12. You might have picked 4 and 6, and that's okay, because whenever you do this, you're going to get the same answers at the end anyway. 2 is a prime number, 12 isn't, so let's split it up into 3 and 4. 3 is a prime number, but 4 isn't, but that does split into 2 and 2. Okay, stick to the cherry colour here. Okay, so far we've found that 24 splits into 2 times 2 times 2 times 3. Let's do the same with 40. So 40, I'm going to split into a 4 and a 10. Neither of those are prime, but 2 and 2 is, and 2 and 5. Circle them when I've done them, and write them in a list. So 40 is 2 times 2 times 2 times 5, which means that my highest common factor is the numbers that appear in both lists. So I've got a 2, I've got another 2, and I've got another 2. 2 times 2 times 2 is 8. So the highest common factor between these numbers is 8. The biggest number that goes into 24 and into 40 is 8. That's what it means. The lowest common multiple, well, we've done a lot of the hard work already. So to work out the lowest common multiple, I'm going to take the 8 that we've just worked out for my highest common factor and multiply it by the things I've not yet used. That was a 3 and a 5. So 8 times 5 times 3. Again, I'm going to do it in a particular order. I'm going to do 8 times 5 first, which is 40, multiplied by 3, which is going to give me 120. So my lowest common multiple is 120. If you did this by yourself, hopefully you got these answers. Well done if you did. If you didn't, I hope that you can now see how we might go about these more challenging questions, or at least these kind of more standard questions. Let's have a look at a challenging question now. In this example, it tells us that Liz has 2 pieces of string. One's 18 centimetres long and the other's 24 centimetres long. She wants to cut them up to produce smaller pieces of string that are all the same length, with no string left over. What's the greatest length in centimetres she can make them? Well, this, on the face of it, doesn't seem like anything to do with prime numbers, factors or multiples. It doesn't say the word factor, multiple or prime number in the question. This is what's called a functional question. It's one of the ones that might have a little star next to it because it might need a wordy answer. Or it might just be a question that is asking you to use your skills, your mathematical skills, and apply them to a wordy question or a real life type question. So let's have a think using common sense what actually is going on here. Visualise that you've got two pieces of string, one and another. We're cutting them to produce smaller pieces of string all the same length, but we don't know how big they could be. Well, we could, if we wanted to, cut them into 1 centimetres. Okay, this one, I'd get 18 1 centimetres going into that piece of string, so I can get 18 1 centimetre pieces, and in this one 24. But that's not what the question asked. The question said, what's the greatest, what's the biggest length that she can make them? Well, this is a highest common factor question. It must be. The biggest thing that goes into two numbers. That's what we've just been working out. It was highest common factor. So very quickly, we can say, right, we're working out highest common factor. Just jot it down somewhere on your piece of paper. Just let everybody know that you know what you're trying to do. Then we can do our prime factors. So 18 splits up into 2 and 9, 2's prime, 3 and 3. And we can do the same with 24. 24 we did earlier with the numbers 2 and 12, I seem to think. So let's do a different pair. Let's do 4 and 6. Not that it makes any difference, but just to prove to you. Okay, and I've circled all my prime numbers. Let's try and just make a little list then. So we said that 18 was the same as 2 times 3 times 3, and 24 is the same as 2 times 2 times 2 times 3. Now we're looking for numbers that are in both lists, and we're going to write one of those numbers down. So we've got a 2 in both lists, and I've got a 3 in both lists. There's nothing else that's in both lists. So my highest common factor is 2 times 3, which is 6. Now, I've worked out some maths. Have I answered the question? Not really. What's the greatest length in centimetres that she can make them? So the greatest length, so you can write this down, greatest length is 6 centimetres. Make sure that somewhere you've answered the question. Here we go, here's another one of these questions. This one's about Helen. She's organising a party and needs some plates and straws. There are 30 party plates in a pack and 120 straws in a pack, and she needs exactly the same number of plates as straws. What's the minimum number of each pack she must buy? Minimum. So straight away we're thinking minimum. That's like the lowest. Could this be a lowest common multiple question? I can hear you asking yourself. Yes, it is. Now, normally, I would say, in any sort of lowest common multiple question, I would be looking at finding the prime factors and then the highest common factor. Let's just try this a slightly different way. I've noticed here the numbers are 30 and 120. If I think of multiples of 30, so remember the word multiple means it's like in the times table, so 30 times table goes 30, 60, 90, 120. I haven't gone through the same process this time. I've used a bit of common sense, I've used a little bit of thought, and thought, oh, I know something about these numbers, 30 and 20. I can see straight away that 30 goes into 120. Let's think about what the question is asking. The minimum number of each pack she must buy. Well, this was 1 pack. This was 2 packs, 3 and 4 packs, and this was 1 pack here. Yet my working's still a little bit messy. How can I tidy this up just a little bit? I'm thinking that I need to label them. These were plates, and these were straws. Just keeping your work tidy and your working out tidy means that when you come, after you've done a lot of maths, you can then go back and look at all the sums that you've done to pick out what it is that you're trying to do. So the minimum number of each pack she must buy, she could buy, so Helen could buy 1 pack of straws and 4 packs of plates. 4 packs of plates. And again, it's not enough just to have written some numbers down. The key parts are that you've labelled it to show you're working, and then you've also written a sentence at this point. Okay, I think we're about ready for you to have a go now. Here are 2 questions for you to try. The first one you need to be a little bit careful with. There's actually 3 numbers here, so you're going to have to use some independent skills. Think about how I've shown you how to work out highest common factor. Do the same thing. The numbers are not particularly easy, so if you want to use a calculator, that's okay. And with the second one, again, set out your working really clearly. Pause the video now, have a go, and I'll show you how you answer these in a second. Okay, let's have a look at answering this question then. The plumber has 3 lengths of copper pipe, 220, 348 and 104 centimetres. He wants to cut them to produce smaller pipes to use in boilers, so they all need to be the same length with no copper left over. What's the greatest length? Okay, so straight away I'm hoping you've realised this is a highest common factor question. Okay, so let's go through the process of splitting these numbers up into their factors then. Let's set out our work nice and neatly as well. So we'll start off with 220, and I can see straight away that that's going to be 22 and 10. Neither of those are prime factors, so we can split this into 2 and 11 and 2 and 5. So we've got 2, 11, 2 and 5. And we also need to write down somewhere in a nice neat place, we'll do it over here, 220 equals 2 times 2 times 5 times 11. Okay, let's do the same with the next number, 348. 348 is a nasty number, that's not one that I know anything that goes into, except for it ends in an 8. So that must mean that 2 goes into it, which means I can halve it. So let's say 2, and what would we be left with? Well, half of 350 is 175. So we've got 1 less than that, so it must be 174. 2's prime, 174 is an even number, so it can't be. So let's halve it again, and we'll have 87 and 2. Okay, now 87, that looks like it might be a prime number. Should we do a little bit of, again, just general thought? 87 is 3 less than 90, and that means that 3 must go into it, because 3 definitely goes into 90. So let's think about how we're going to do this. So 3 and I'm not quite sure how many times 3 goes into 87. So again, on the side of my work somewhere, I'm just going to do a little bit of bus stop method. 3 is into 87. 3 goes into 8 2 times, remainder 2, and 3 goes into 27, 9. So I've got 29, which I know is a prime number. This is why it's well worth you knowing some of your prime numbers past the first few. Nothing else goes into 29. 29 is not in anybody else's times table apart from the 1 times table and the 29 times table. Okay, so again, I've done some work. Before we get carried away doing the next bit, let's keep it tidy. 348 is 2 times 2 times 3 times 29. Okay, and again, let's do the last one, 104. 104. I'm going to halve it, 2 and 52. That gives me a little bit of time whilst I'm circling that to think about what half of 52 is. Well, a half of 50 is 25, so 2 more must be 26. So again, I've got 2 and 26. And 26 splits up into, again, 2 and 13. And 13 was on my list before. So I've got my list of prime numbers before. So I've got 104 is 2 times 2 times 2 times 13. Okay. At that point, I need to look to see what numbers are in both. And I can see I've got a 2 in all of them. So my highest common factor is going to be 2. And I've got another 2 here that's in all of them times 2. And that's it. All the other numbers are different. So the highest common factor is 4. In terms of answering the question, what's the greatest length in centimetres that you can make the pipes? 4 centimetres. Okay, if you manage to do that, that's really, really good. I haven't shown you at this point how to do it with 3, but I was hoping that you would be able to see the process here being exactly the same. We're finding numbers that are in all of the lists. That's why they're common. Okay, so this is the bit that makes it common. Okay, let's look at the last one. This one, a school purchases workbooks in packs of 25 and textbooks in packs of 15. School is exactly the same number of workbooks as textbooks, so they can be paired up for the students. Again, I'm thinking this time, shall I do my prime factor decomposition? You can do if you want, or I might do, because the numbers are quite nice, I might do work books, so 25, 50, 75, 100, 125, 150. I don't really know how far to go with these, but I've made a little list and I'm going to stop there. Let's do the same with the textbooks. Let's do my 15 times table. So 15, 30, 45, 60, 75. Oh, 75. I've noticed here, 75. Now, if you're not confident doing adding up in 15s or in 25s, that's fine, and you can use the prime factor tree. You will get the same answers. This way, I think, is quite nice in terms of answering these questions. What does it say? What's the minimum number of each pack that must be bought? So we must buy 1, 2, 3 packs of workbooks. So 3 lots of workbooks. And we must buy 1, 2, 3, 4, 5 lots of textbooks. 5 times text book. Okay, again, if you got that right, really well done. So if you've been watching these videos, you'll notice that we always do a revision card note section at the end where you can make some notes on this. I'm hoping that what you might write down here is a small guide on how to do your prime factor decomposition. You might want to make a little note of your prime numbers going up to whatever you like. Okay, it's well worth knowing some of these, 29 and so on. I've said on the right hand side that it would be great if you knew them as far as this, but if you don't, getting to this far is really good. Okay, these are something to learn. Remember that when you're writing your numbers down and you've got your first list of numbers that might look like this, and you've got your second list of numbers that might look like this, when you're pairing them up, you only write down one of the numbers in that pair. So in this case it'd be 2 times 2 times 3. That would be it, which in this case is 12. Okay. Your lowest common multiple, remember, we are then using this multiplied by all the things that I've not yet used. So multiply by your leftovers. And it's as simple as that. This isn't a simple exercise. There's a lot of things to do, but the process, if you learn it, you won't go wrong. Okay, hopefully this has been useful. Good luck in any exams or tests that you might have coming up, and for more information, as I've said before, you can always ask on Twitter. Thanks, bye.